Numerical number 10, Kinematics 1. Given x equals 7t plus 4t square meter and y equal to 5t meter. Displacement along x-axis is x and displacement along y-axis is y, which is 5t meter. And the value of time is given 5 seconds and we have to find the resultant acceleration A. The instantaneous acceleration, the velocity, not the acceleration, the velocity of the body along x-axis. Velocity of the body along x-axis, or that is instantaneous velocity of the body along x-axis is given by Vx equal d by dt, that is ddt of x, ddt of x equal ddt, putting the expression of x, 7t plus 4t square, 7t plus 4t square, ddt 7t bracket closed plus ddt of 4t square, not 7t square, it should be 7t bracket close ddt of 4t square, seven ddt of t, it should be t, not t square, ddt of t, plus 4 is constant, we can bring 4 outside ddt, ddt of t square, seven is constant, that is brought outside ddt, and 4 is also constant, that can be brought outside ddt operator. 7 and ddt of t is 1 plus 4 and ddt of t square is 2t from by using the formula. Hence we get the expression of velocity of the body, instantaneous velocity of the body along x-axis. Therefore Vx equal (8t plus 7 meter per second). Vx equal 8t plus 7 meter per second. That is the velocity of the body along x-axis. Vx equal 8t plus 7 meter per second. 8t plus 7 meter per second. Similarly, the velocity of the body along y-axis. The velocity of the body along y-axis. Velocity of the body along y-axis. Along y-axis is Vy equal, similarly the velocity of the body along y-axis is given by Vy equal ddt of y, ddt, putting the expression of y is 5t. Now 5 is constant, we can bring 5 outside ddt operator. 5 ddt of t, 5 into 1, ddt of t is 1. 5 is constant, that can be brought outside ddt operator, and ddt of t is 1. So hence we get the velocity of the body along y-axis as Vy as 5 meter per second. 5 meter per second. Again, acceleration of the body. Again, acceleration of the body. Acceleration of the body along x-axis is ax equal ddt of vx. Ax equal ddt of vx. Ddt of vx. Now putting the expression of vx ddt, and vx is 8t plus 7. From this expression it is 8t plus 7. 8 into t plus 7. Now operating ddt over 8t and 7. So ddt of 8t plus ddt of 7. Now 8 is constant. We can bring 8 outside ddt. Ddt of t plus 7 is constant, that's why it is 0. 8 and ddt of t is 1. Hence we get ax as 8 meter per second square. That is the acceleration of the body along x-axis. 8 meter per second square. Meter per second square. Again, the acceleration of the body along y-axis. The acceleration of the body along y-axis. Acceleration of the body along y-axis is ay equal ddt of vy. Derivative of velocity along y-axis with respect to time. Ddt of vy. Ddt vy is most probably 5, that is 5. Ddt of 5 is constant, that's why ddt of 5 is 0, and we get the acceleration of the body along y-axis as 0. Ay equal 0. Therefore, if we draw a diagram, that is acceleration of the body along x-axis and along y-axis, acceleration of the body along y-axis is ay, this is y-axis and x-axis, and along x-axis acceleration is we can denote acceleration of the body along x-axis up to this point and along y-axis up to this point. This is ay and this length is ax, acceleration of the body along x-axis. And if we use parallelogram law of vector addition, then along this direction resultant acceleration a will be acting. Ax is the acceleration of the body along x-axis and ay is the acceleration of the body along y-axis. Ax and ay, and a is the resultant acceleration along this diagonal. Resultant acceleration of the body is the resultant acceleration of the body is a equal root over ax square plus ay square, ax square plus ay square. Therefore, a equal to root over ax is what you know, 8, and ay is 0. Ay is 8 square, and then 5 square, that is 0 square. Ay is 0. And here we can write root over ax square plus ay square plus 2ax ay cos 90 degree, because ax is perpendicular to ay, cos 90 degree. Ax is perpendicular to ay, that's why you have to consider the angle between x and ay as 90 degree. So that's why third term is 0 due to cos 90 degree. So therefore we get the value of resultant acceleration, which is 8 meter per second square. Resultant acceleration of the body is 8 meter per second square, which acts along x-axis, because acceleration of the body along y-axis is 0. Therefore at instant 5 second, and this acceleration is constant, that's why acceleration will be again same, 8 meter per second square. Ay and ay is 0, that's why resultant acceleration will be acting along x-axis. Therefore, the acceleration of the body at the instant, therefore the resultant acceleration of the body at instant 5 second is 8 meter per second square, which acts along x-axis.